Hello everyone, welcome to this session of Class 6 Mathematics, and I am your Anu for MathSchool.1. Now we are seeing the chapter playing with numbers, and the last class I have told you about LCM, how to find LCM by prime factorization method and the long division method, isn't it? So HCF and LCM plays very important role in fractioning numbers. So that is for HCF, we use HCF, and LCM is determining the same incident happening again simultaneously. It is happening after a point of time, so we calculate the duration of time when the same incident or the same incident done by many people repeat itself after some point of time, isn't it? I told you about that. Now in this chapter we'll move on to the next topic, that is while calculating HCF and LCM, the one thing we struggle with is we find numbers, that is for bigger numbers, we find it very difficult to find the factors, isn't it? For finding HCF we find it very difficult, but in prime factorization method it is easier for you. But the rest of the part, Euclid's algorithm, or for finding factors, we might find it sometimes, people might find it difficult to find the factors. So there is another method by which we can find out the divisibility of certain numbers by some numbers. Initially from 2 to 9 and up to 11 we can make it by heart, and then for some numbers we can just remember them, or we can just note it down at some place so that it will be useful for us in certain places where bigger numbers are asked for. So let us start with a simple number, say 2. So today we are going to see about the test of divisibility. The test of divisibility, what does it mean? It means we find out whether a number is divisible by another one, whether a bigger number is divisible by another smaller one. So what are the rules to be followed, or what are the points to be noted for the number to be divisible by another number? Okay, so let's start with 2 now. 2 is a very simple number, single digit number. You know 2 is an even number. So 2 divides any even number which ends with 0, 2, 4, 6 and 8. We know that, isn't it? So this is very easy for us to find out whether a number is divisible by 2 or not, because in prime factorization method, if it is an even number, we just start with 2, isn't it? It will be very easy for us. So this is for 2. So we see for 0, 2, 4, 6 and 8 in the units place. If it is in the units place, if these numbers are in the units place, we understand that it is an even number, and it is divisible by 2 perfectly. Now next is 3. Now how do we find out whether the number is divisible by 3 or not? Of course 3 is an odd number, but the multiples are even numbers too, isn't it? Like 12, 18, 24 and so on. So how do I find out? Say for example, if a number 27 is there, if a number 27 is there, then how will we find out whether 27 is divisible by 3 or not? Just add the numbers just add the digits in the number. That is 2 plus 7. 2 plus 7 will give you 9. If the sum of digits in the number is divisible by 3, then the number is divisible by 3. So that is the rule. Okay. So if the sum of digits is divisible by 3, then the number is divisible by 3. So that is the rule to find out whether a number is divisible by 3 or not. Say for example, I take 243. I just add 2 plus 4 plus 3. It gives me 2 plus 4 is 6. 6 plus 3 is 9. Now 9 again is divisible by 3. Therefore 243 is divisible by 3. So for how many times it goes, that you need to divide itself. Okay. So this is the rule for number that is to be divisible by 3. And for 4, so there is no particular thing for 4 like 2 or 3. What we do is, if it is a 3-digit number, say for example 64 into 4 by 2, I get 256, isn't it? So if it is a 3-digit number, 3-digit or more than that, we see the last two numbers, last two digits. If the last two digits is divisible by 4, then the whole number is divisible by 4. See 56, so 56 is divisible by 4. How many times? 14 times, isn't it? So 256 is divisible by 4. So if it is a 3-digit number, 3-digit or more than 3-digit, you just see the last two digits, that units and tens place you see. If that number is divisible by 4, then the whole number is divisible by 4. Okay. So that is the rule for number to be divisible by 4. 5 is very easy for us, because if the units place ends with 0 and 5, we say that the number is divisible by 5, of course. Then by 6. 6 is, see, if you take 6, the factors of 6 are 2 and 3. So any number which is divisible by 2 and 3, not 2 or 3, it should be divisible by 2 as well as 3. So for 2, how will you find out? You see the units place 0, 4, 2, 4, 6, 8. If the units place is even number, then if the sum of numbers if the sum of the digits in the number is divisible by 3, then it is divisible by 3, the number is divisible by 3. If these two rules together apply for that rule, then that is also divisible by 6. So a number, if the number is divisible by both 2 and 3, so that is the rule, by both 2 and 3, then it is divisible by 6. So that is the rule for 6. Now what about 7? Now what about 7? Actually 7 comes under these numbers category, but as we are going according to the numerical order, let me say for 7 too. So for 7, how do you know that it is divisible by 7 is, say for example, if you have 49, let me take it as 49. Okay, so take the last digit, take 9 and double it. 2 into 9 will give you 18, isn't it? 2 9s are 18. So take the last digit, double it and subtract it with the remaining digits. So here just 4 is there, so subtract it with 4, then 18 minus 4 is 14. Now 14, you know, it is divisible by 7, isn't it? So therefore 49 is also divisible by 7. Now this is just for 2 digits, and 2 digits is easier for us because if we remember the tables, we can just find it out. But in case if it is 3 numbers or 4 numbers, when we double the units digit and subtract it with the remaining digits, we again get a triple digit or a double digit number. So again what we need to do is again double the last digit and subtract it with the rest of the digits, and then you can find out until you get a simple 2-digit number which is divisible by 7, which is, if it is divisible by 7, that is, if the number is divisible by 7 or you get an answer 0, then in both the cases it is divisible, the number is divisible by 7. Okay. Now up to 7 we have seen. Now the next is 8. Now the rule for divisibility, the test of divisibility for 8 is just like 4. For 4 we said we started with 3 digits, isn't it? For 8 we start with 4 digits. Any 4 digit can be taken. So any 4 digit like 3, 2, 6, 4 I take. Okay. So if I say, see, for 4 digits and more than 4 digits we have to see for 8. Other than 4 digit, if it is less than 4 digit, if it is a 3-digit number, then you need to divide and see whether it is divisible by 8. So more than 4 digits, see 4 digit and more than 4 digit, you see the last 3 digits. Units, tens and hundreds place, up to hundreds place you take, you see the last 3 digits and see if it is divisible by 8. See 264, if I divide it by 8, it will give me 8 3s are 24, again 3. Okay. So 33 times 264. So this is 264 is divisible by 8. Therefore 3264 is also divisible by 8. Okay, so that is the criteria for test of divisibility of 8. It is just like 4. For 4 we take just 2 digits, last 2 digits, and for 8 we take 3 digits. Okay, now the next one is 9. 9 is just same as 3. We see, we write a number and add all the digits, sum of digits we take, and if the sum of digits is divisible by 9, then we say that the number is divisible by 9. Say 99, if I take 99, 9 plus 9 is equal to 18, isn't it? So 18 is divisible by 9, so we say 99 is also divisible by 9. Okay, now 10, it is very easy because units place, if we see is 0 in units place, it is divisible by 10. Now the next one is 11. Now what is the divisibility criteria for 11? Now we should understand it clearly. Let me write 3, 4, some number 3, 4, 7, 5. So just to explain, so I write some 5-digit number and mark the places, that is first place, second place, third place, fourth place, and fifth place. Now this first 3 and 5, 1, 3 and 5 are odd places, and this 2 and 4 are even places. We need to mark it like that. Okay, now what I need to do is I add all the odd places. So sum of odd places, see sum of odd places, SO I write, sum of odd places is 6 plus 7, 13, 13 plus 3 is 16. Okay, now sum of even places, see sum of even places, SE I write, sum of even places is 4 plus 5, that is 9. Okay, I should find the sum of odd places and even places in a number and then subtract these two. Okay, I should find the difference between these two sums. So when I subtract these two, I get 7. What is that is, the rule is, if I get the difference to be 11 or 0, if it is 11 or 0, then the number is divisible by 11, otherwise it is not. So if you get 7 or any other number which is not divisible by 11, then it is not divisible, the number is not divisible by 11. So when you get the difference as 11 or 0, then the whole number is divisible by 11. Do you understand the rule for divisibility of 11? Okay, so that is the case. Now we have learnt about the test of divisibility up to 2 to 11 we have done, and some of the numbers I have written here. See, for 13 it is the remaining digits, that is like 7. See what I did for 7, 2 into last digit and subtract it with the remaining digits. Then if it gives you 7 or 0, if it gives you 0, well and good, you that number is divisible by 7. Or else if you get 7 or number which is divisible by 7, that is 14 or 21, then it is also divisible by 7. Likewise you have for 13, that is last digit into 4 plus the remaining digits. If you get 13 or a multiple of 13, then that is divisible by 13. Then for 19, multiply it by 2 and add it with the remaining digits. Then for 33, likewise 7 into last digit plus remaining. For 29, 3 into last digit plus remaining digit. For 43, it is 13 into last digit plus remaining digits. Likewise for 7 and 17, it is 5 into last digit minus remaining digits. 31, 3 into last digit minus remaining digits. 11 into last digit minus remaining digits for 37, and 4 into last digit minus remaining digits for 41. So these are some of the numbers, and when you observe, these numbers are prime numbers, so it will be useful for prime factorization when you do such if these are some rare numbers, but when you struggle to find out the factors, in some cases bigger numbers, they may yield prime. When you prime factorize them, you can have some of these numbers, so it will be easier for you to remember these shortcuts to find the divisibility of these numbers. Okay, so you just go through, when you see this part of playing with numbers, when you see this part, you can slow it down and you can also note it down, these test of divisibility of these numbers. Okay, so this class we have seen about the test of divisibility of some numbers, which will help you in finding HCF or to prime factorize. Okay, so that's it for this class, and we have come to an end of this chapter. Now next class we will be seeing some problems in your exercises or general problems. I'll be taking maximum possible models of all kinds, so that it will be easier for you to understand what is HCF, what is LCM, and what is prime number, composite number. We'll touch everything, we'll go through everything in the problem so that you'll have an idea. So I'll be doing sums like for HCF and LCM too. Maximum possible sums we'll do so that you will get an idea about HCF and LCM also. So in the next class we'll be doing some problems in the chapter. So with this we come to an end of this chapter, playing with numbers. In the next class we'll be seeing some problems, and we'll go to the next chapter after that. So until then, it's bye from Anu from maxschool.1. Thank you.